Hey guys, I'm Simon. Today we're going to take a look at how do we use a 7-segment display. So we're going to look at the pins on the back. How do I connect these up? What's the pin out? What's the polarity? What size of resistor do I need to drive this thing? And how do I turn the BCD code in my circuit into usable numbers on the display? Okay, let's get started. Okay, so here we're going to take a look at the specification. The particular 7-segment ID that I'm 7-segment display that I'm looking at is the FJ5101AH. This is typical of this kind of product. It's a common cathode type. And we can see here on the spec that the continuous forward current, this is sort of the maximum, is 20 milliamps, and the recommended current is around 5 to 10 milliamps. So we'll talk about determining that in a little while. If I scroll down here, we can see that the forward voltage on the display, okay, I'm using a red one, super red, so they're saying here that it's typically in the region of 1.85 to maximum 2.3, so let's say around 2 volts. Let's just scroll down further to the drawing of the display here. I'm just going to zoom a little bit so we can get it on the screen, and you'll see it shows the 7 segments, the decimal point, and it shows that pin number 1 is the bottom left corner when it's oriented correctly. This display, I'm going a little further down here, it shows the internal circuitry. So you see with the common cathode type that all of the segment cathodes are tied together. In this case, the display has 10 pins, which is sort of odd because we have 7 segments, but remember there's also a decimal point. This is number 5 here. And what they do is they provide 2 common pins, one at the top and one at the bottom for convenience. So 7 segments plus the decimal point plus 2 common is 10 pins. Let's take a look at the actual displays themselves. You can see here I have 2. They look identical, but actually they're not. If I can turn this so you can see the model number. Here you can see this is FJ5101AH, and this is actually BH. So the AH is a common cathode type and the BH is a common anode type. They look identical, but they are actually different. So now we'll talk about the pinout of these. Just like an IC, the pinout starts here with pin 1 and goes counterclockwise all the way to pin 10. The decimal point is generally pin 5. The center pin at the bottom and the top is the common pin. So on this one it's the cathode, it's the common cathode, and on this one it's actually the common anode. So now let's connect this to a 5-volt supply. I have it preset here. I'm just going to plug it in, and you'll be able to see the segments light up. And we're also going to measure the voltage drop across this device so we can calculate what resistor value we should have. I'll show you that shortly. So here I'm just going to plug in across one of the segments, and there you see the center segment light up. I'll light up the decimal point here. There it is. And as you go around you can see each segment lighting up. So if you're not sure, this is one way that you can kind of figure it out as well, if the spec's not clear to you. So there you go. You see the different segments lighting up. Here I'm using a small resistor in the few hundred ohms range. I'll show you how to determine that in a little while. Now let's just put a voltmeter across this and see what kind of voltage drop we get. According to the spec, it's approximately 2 volts. So let's just test that out, see if we match up with what the specification says. I kind of have the voltmeter pre-wired here, so I'll just plug into the ground. Just move that over to make room. We'll plug into the ground here. And let's go across where we're lighting up one segment. And my voltmeter is saying, let's see if you can see that, 1.972 volts, approximately 2 volts essentially. And there's probably a little bit of error in the meter. Okay, so there you go. That's the basic hookup. Okay, so how do we convert the binary in our circuit, whatever we're using to drive this IC, say a microprocessor? How do we take the binary output from that circuit and create the 7 segments that we need to drive the display? We need a 7-segment decoder driver like the 4511. You can see a more detailed description of this in one of the other videos I've made. So with this circuit, which is very nicely provided to us by the engineers at Texas Instruments, for example, this looks like circuit spaghetti here, but we don't have to worry about that because it's internal to the chip. All we have to know is that if we put our binary 1 through 8 here, so that's all we need to provide 0 to 9, which is what each display can handle, 0 to 9. So if we stack 2 displays together, we can go up to 99, or 3, we can go up to 999. What happens here is when you put a high on the 1 pin, that is converted to the correct segment high on this pin here. When we put a high on the 2 pin, same thing. It selects the correct segments in order to light up a 2 on the display. If we put a high on both of these, we have 1 and 2, which is 3. It'll light up the right segments to put a 3 on the display, and so on. So that's how we drive the 7-segment display. Okay, if we now take a look at how do we determine the series resistor for the display. If we have a display driver such as the 4511, it's putting out 5 volts on the driver pins. We have the series resistor going into the 7-segment display. In this case, we'll use a common cathode, so the common pin connected to ground. If we look at our example circuit for one segment here, it's going to look something like this. We're going to have 5 volts coming in, the series resistor, and then the segment, which is really an LED. And we know from our previous work that we're dropping about 2 volts across this segment. If we have a 5 volt supply, that must mean there's 3 volts across the resistor. And we know from the specification that we want to have approximately 5 to a maximum of 200 milliamps. 5 milliamps, the display is going to be fairly dim. Let's look at 10 milliamps. So we can use simple Ohm's law, R equals V over I. So if we use this, we know that our voltage is 3 volts. We want 10 milliamps current, so that comes out to 300 ohms. So if we use a common value like 330 ohms, we'll be okay. If we want a little bit brighter display, let's say we use a common value of 220 ohms in our calculation. Again, Ohm's law, I equals V over R, so I is equal to 3 volts over 220 ohms, and we'll find that we're running at about 13 milliamps, which again is safe. It's below our 20 milliamp maximum value. So that's how we determine the series resistor. I commonly use both these values, 220, 330, depending on how bright I want the display to be. So I don't have to keep calculating it over and over again. I just know that I can use those values safely.